In this video, we are going to talk about the different factoring techniques used in algebra. The first type is factoring polynomials with common monomial factor. Example number 1, factor 36m to the power of 4 n squared plus 48mn to the power of 4. So we have two terms here. So we are going to find the greatest common factor between the two terms. First, the greatest common factor between 36 and 48 is 12. And the greatest common factor between m to the power of 4 and m is the one that has the lower exponent, and that's m. And the greatest common factor between n squared and n to the power of 4, it's the one that has the lower exponent, and that's n squared. 36m to the power of 4 n squared divided by 12mn squared equals 3m cubed. And 48mn to the power of 4 divided by 12mn squared equals 4n squared. So these are the factors: 12mn squared times the quantity 3m cubed plus 4n squared. Example number 2, factor 5x cubed y squared plus 15x squared y minus 20xy. We have three terms here. So the greatest common factor between 5, 15, and 20 is 5. And the greatest common factor between x cubed, x squared, and x is the one that has the lowest exponent, and that's x. The greatest common factor between y squared, y, and y is just the y. 5x cubed y squared divided by 5xy equals x squared y. 15x squared y divided by 5xy equals 3x. Negative 20xy divided by 5xy equals negative 4. So these are the factors: 5xy times the quantity x squared y plus 3x minus 4. Second factoring technique, it's factoring the difference of two squares. So this is our pattern: a squared minus b squared equals the quantity a plus b times the quantity a minus b. So that means the factors are the product of the sum and difference of two terms. Where do the two terms come from? They are just the square roots of the first and second terms. Square root of a squared is a, and square root of b squared is b. Let's do example number 3. Factor x squared minus 9. So it's the product of the sum and difference of two terms. So square root of x squared is x. So we write here x here and x here. And then the square root of 9 is 3. So we write 3 here and here. And it's the product of the sum and difference of the two terms. So we will place plus and minus. So this is our answer: the quantity x plus 3 times the quantity x minus 3. Example number 4, factor 4m squared minus 25. Again, it's the product of the sum and difference of two terms. Square root of 4m squared is 2m, so we write 2m here and 2m here also. Square root of 25 is 5, so we write 5 here and 5 here also. Because it's the product of the sum and difference of two terms, we put plus and minus. So this is our answer: the quantity 2m plus 5 times the quantity 2m minus 5. The third factoring technique is factoring perfect square trinomials. Example number 5. Factor x squared minus 6x plus 9. Since it's a perfect square trinomial, the factors are the square of a binomial. The first term here is just the square root of x squared, which is x. The sign of the middle term is negative, so it's also the sign of our second term. And the second term is just the square root of 9, which is 3. So it's the quantity x minus 3 squared, or it can be written as the quantity x minus 3 times the quantity x minus 3. Example number 6. Factor 4m squared plus 20m plus 25. Since it's a perfect square trinomial, the factors are the square of a binomial. The first term here is just the square root of 4m squared, which is 2m. The sign of the middle term is positive, so this is also the sign of our second term. And our second term here is just the square root of 25, which is 5. So it's the quantity 2m plus 5 squared, or it can be written as the quantity 2m plus 5 times the quantity 2m plus 5. Example number 7. Factor 36x squared minus 12xy plus y squared. Since it's a perfect square trinomial, the factors are the square of a binomial. Our first term here is just the square root of 36x squared, which is 6x. The sign of the middle term is negative, so it's also the sign of our second term. And our second term here is just the square root of y squared, which is y. So it's the quantity 6x minus y squared, or it can be written as the quantity 6x minus y times the quantity 6x minus y. The fourth factoring technique is factoring quadratic trinomials of the form ax squared plus bx plus c, where a equals 1. Example number 8. Factor x squared plus 8x plus 15. So there are two binomial factors. First, we are going to factor the first term. So the factors of x squared are x and x. Then we are going to factor the last term, but we are going to choose factors whose sum equals the coefficient of the middle term. So the factors of 15 are 3 times 5, negative 3 times negative 5, 1 times 15, negative 1 times negative 15. And which of these factors will give us the sum of 8? So it's 3 and 5. So that means plus 3 and plus 5. So this is our answer, the quantity x plus 3 times the quantity x plus 5. Example number 9. Factor x squared minus 7x minus 18. Again, there are two binomial factors. First, we are going to factor the first term. Factors of x squared are x and x. Then, we are going to factor the last term, which is negative 18. But we are going to choose factors whose sum equals the coefficient of the middle term. And these are the factors of negative 18. Among these factors, which pair gives us the sum of negative 7? It's 2 and negative 9. So we write minus 9 and plus 2. So this is our answer, the quantity x minus 9 times the quantity x plus 2. Fifth factoring technique. So it's factoring quadratic trinomials of the form ax squared plus bx plus c, where a is not equal to 1. Example number 10. Factor 2x squared plus 11x plus 5. So first, we are going to factor the first term. So the factors of 2x squared are 2x and x. Then we are going to factor the last term. Our method here is guess and check method. We check to make sure that the sum of the inner and outer products equals the middle term. So first we are going to guess the factors of 5. That's positive 1 and positive 5. Now let's check. 1 times x, it's x, so it's the inner product. Then the outer product, that's 2x times 5, and that's 10x. If we are going to add x and 10x, that gives us 11x. So this means the factors, the quantity 2x plus 1 and the quantity x plus 5 are the correct factors. Example number 11. Factor 3x squared plus 5x minus 12. First, we are going to factor the first term. So the factors of 3x squared are 3x and x. Then we are going to factor the last term. So our method here is guess and check. So we check to make sure that the sum of the inner and outer products equals the middle term. So let's guess that the factors of negative 12 are positive 2 and negative 6. And let us check. The inner product, that's 2 times x, that's 2x. Then the outer product, 3x times negative 6, that's negative 18x. So if you are going to add 2x and negative 18x, it's not equal to 5x. So these are wrong factors. So we will guess again. So this is our second guess. Now let's check. Negative 4 times x, that's the inner product, that's negative 4x. Then 3x times 3, that's 9x, that's the outer product. Then we add negative 4x plus 9x, it's 5x. So this means the quantity 3x minus 4 times the quantity x plus 3 are the correct factors. The sixth factoring technique, it's factoring the sum of two cubes. So this is our pattern. A cubed plus b cubed equals the quantity a plus b times the quantity a squared minus ab plus b squared. So we have two factors here. One is a binomial factor and the other one is a trinomial factor. So where do these terms come from? So the cube root of a cube is a, and the cube root of b cube is b. So we have a plus b as our binomial factor. Where do the terms in our trinomial factor come from? So first term here is a squared, meaning to say we just square the first term of our binomial. Then we have ab, that means we just multiply a times b, but the product here is positive, so we will just make it negative, so that's why it's negative ab. The last term here is b squared, it's just the square of the second term here, b. Now we will follow this pattern in factoring example number 12. Factor x cubed plus 8. The cube root of x cubed is x, and the cube root of 8 is 2. So our binomial factor is x plus 2. Then our trinomial factor is the square of x is x squared, and then x times 2 is 2x because the product is positive, so we'll make it negative. So that's negative 2x. And then our third term here is just the square of 2. 2 times 2 is 4. So these are the factors. The quantity x plus 2 times the quantity x squared minus 2x plus 4. Example number 13. Factor 27m cubed plus 1. The cube root of 27m cubed is 3m. The cube root of 1 is still 1. So our binomial factor is 3m plus 1. Then for our trinomial factor, 3m squared is 9m squared. Then 3m times 1 is 3m. Because the product is positive, we'll make it negative, so it's negative 3m. Then the last term here is the square of 1. 1 times 1 is 1. So these are the factors. The quantity 3m plus 1 times the quantity 9m squared minus 3m plus 1. The seventh factoring technique, it's factoring the difference of two cubes. Our pattern here is a cube minus b cubed equals the quantity a minus b times the quantity a squared plus ab plus b squared. So where do the terms come from? So the cube root of a cube is a, and the cube root of negative b cube is negative b. So this is our binomial factor. A times a is a squared. A times negative b is negative ab. Because it's negative, we'll make it positive ab. And then negative b times negative b is positive b squared. Now we will use this pattern in factoring example number 14. So factor x cubed minus 27. So the cube root of x cubed is x. The cube root of negative 27 is negative 3. So our binomial factor is x minus 3. For our trinomial factor, x times x, that's x squared. Then x times negative 3, that's negative 3x. Because it's negative 3x, we'll make it plus 3x. Then our last term here is the square of negative 3. So negative 3 squared is positive 9. So these are the factors. The quantity x minus 3 times the quantity x squared plus 3x plus 9. Example number 15. Factor 216 d cubed minus 343 e cubed. The cube root of 216 d cubed is 6d, and the cube root of negative 343 e cubed is negative 7e. So this is our binomial factor, 6d minus 7e. Now for our trinomial factor, 6d times 6d is 36d squared. 6d times negative 7e is negative 42de. Because it's negative 42de, we will make it positive 42de. Then the last term here is just the square of negative 7e. That is negative 7e times negative 7e, that's 49e squared. So these are the factors. The quantity 6d minus 7e times the quantity 36d squared plus 42de plus 49e squared. Factoring technique number 8. So it's factoring by grouping. Example number 16. Factor 6xy plus 10x plus 15y plus 25. So first, I will create two groups. So this is the first group, and then this is the second group. So I have to factor each group. The greatest common factor between 6xy and 10x is 2x, and then 6xy divided by 2x is 3y, and 10x divided by 2x is positive 5. I also have to factor the second group. The greatest common factor between 15y and 25 is 5, and then 15y divided by 5 is 3y. 25 divided by 5 is positive 5. The greatest common factor in our first group is 2x, and the greatest common factor in our second group is 5. Our first binomial factor is the sum of 2x and 5, so that's 2x plus 5. Our second binomial factor is the common binomial factor between the two groups, that's 3y plus 5. So these are the factors, the quantity 2x plus 5 times the quantity 3y plus 5. Example number 17. Factor a squared b squared plus 3a squared minus 2b cubed minus 6b. First, I have to create two groups. So this is the first group. This is the second group. Notice here that when I enclose these two terms with parentheses, the sign of the second term changes. It's because this negative sign is to be distributed to the two terms. So if we are going to remove the parentheses, it's going to be negative times 2b cubed, it's negative 2b cubed, and then negative times positive 6b equals negative 6b. Now we are going to factor the first group. The greatest common factor between a squared, b squared plus 3a squared is a squared. Now a squared, b squared divided by a squared is b squared. Then 3a squared divided by a squared is just 3. And the greatest common factor between 2b cubed and 6b is 2b. And 2b cubed divided by 2b is b squared. Then 6b divided by 2b is 3. On our first group, the greatest common factor is a squared. And on our second group, it's negative 2b. So a squared minus 2b is our first binomial factor. And the second binomial factor is the common binomial factor between the two groups. And that's b squared plus 3. So these are the factors. The quantity a squared minus 2b times the quantity b squared plus 3. Example number 18. Factor 3m cubed plus 10np minus 2mn minus 15m squared p. Here we need to rearrange our terms. So this is the first group, 3m cubed minus 15m squared p. Then for our second group, it's going to be 2mn minus 10np. Notice here again that the sign of positive 10np here becomes negative 10np. That's because of this negative sign outside the parentheses. Because if we are going to distribute this negative sign to the two terms, it's going to be negative 2mn, this one, and negative times negative 10np is positive 10np. Now we are going to factor the first group. So the greatest common factor between 3m cubed and 15n squared p is 3m squared. Now 3m cubed divided by 3m squared is m. Negative 15m squared p divided by 3m squared is negative 5p. Now we are also going to factor the second group. The greatest common factor between 2mn and 10np is 2n. Then 2mn divided by 2n equals m. Then negative 10np divided by 2n equals negative 5p. The greatest common factor in our first group is 3m squared, and on our second group it's negative 2n. So our first binomial factor is 3m squared minus 2n, and the second binomial factor is the common binomial factor between the two groups. So that's m minus 5p. So these are the factors. The quantity 3m squared minus 2n times the quantity m minus 5p. The ninth factoring technique is applying more than one type of factoring. Example number 19. Factor negative 7p cubed q squared plus 63p q to the power of 4. The greatest common factor between the two terms is negative 7p q squared. and then negative 7p cubed q squared divided by negative 7p q squared equals p squared, and 63pq to the power of 4 divided by negative 7p q squared equals negative 9q squared. Then we can still factor this binomial here, p squared minus 9q squared. It's the difference of two squares. So I'll copy down negative 7pq squared, and the factors of p squared minus 9q squared are the quantity p plus 3q times the quantity p minus 3q. So these are the factors. Negative 7pq squared times the quantity p plus 3q times the quantity p minus 3q. Example number 20. Factor 6x cubed y plus 24x squared y squared plus 24xy cubed. The greatest common factor between the three terms is 6xy. 6x cubed y divided by 6xy equals x squared. 24x squared y squared divided by 6xy is positive 4xy. Then 24xy cubed divided by 6xy equals positive 4y squared. We can still factor what we have inside the parentheses. It's a perfect square trinomial. So we will copy down 6xy, and then the factors of x squared plus 4xy plus 4y squared are the quantity x plus 2y times the quantity x plus 2y. So these are the factors. 6xy times the quantity x plus 2y times the quantity x plus 2y. Example number 21. Factor m to the power of 4 minus 81y to the power of 4. So this is the difference of two squares. So the factors are the quantity m squared plus 9y squared times the quantity m squared minus 9y squared. The second binomial factor m squared minus 9y squared can still be factored. It's the difference of two squares. So we will copy down our first binomial factor, m squared plus 9y squared, and we are going to factor m squared minus 9y squared. And the factors are the quantity m plus 3y times the quantity m minus 3y. So these are the factors. The quantity m squared plus 9y squared times the quantity m plus 3y times the quantity m minus 3y. Thanks for watching, guys. This is Teacher Rejil. Keep safe.